solve this equation by graphing. Well, looking at our equation, we have a polynomial set equal to 0. And in order to graph, we need to have a y value. So for now, let's pretend that the 0 is a y. That way we can graph this. Now, in order to graph a parabola, we need to locate the axis of symmetry. Remember, the axis of symmetry is the invisible line that cuts the parabola in half. And the formula for the axis of symmetry is x equals negative b over 2a, where a is the coefficient in front of x squared and b is the coefficient in front of x. When we plug in those values, we get negative 12 over 2 times 1. This reduces to negative 6. So we found our axis of symmetry. Our axis of symmetry for this parabola is the line x equals negative 6. Now that we found the axis of symmetry, let's work on finding the vertex. The vertex is the point that's shared by both the axis of symmetry and our parabola. So it has the x value of negative 6, since it lies on the axis of symmetry. That means we already know half of our vertex. Our x-coordinate is negative 6. Now we just need to find our y-coordinate. To do that, we take negative 6 and plug it into our expression. So we have negative 6 squared plus 12 times negative 6 plus 32. When we simplify this expression, we get negative 4. That means when x is negative 6, y is negative 4. So our vertex is negative 6 comma negative 4. Next, let's identify some more points that lie on our parabola. To do this, let's make a table. So we need to start by picking some x values. Well, let's pick x values that are on either side of our vertex, so we can see what the points are doing on either side. So we'll pick a few values that are bigger than and smaller than negative 6. We'll pick x to be negative 4, negative 5, negative 6, negative 7, and negative 8. Great! Now we need to take each one of those values and plug them in to our polynomial. So we take negative 4 and plug it in. We get negative 4 squared plus 12 times negative 4 plus 32. Then we do the same thing for negative 5. And we keep repeating this process for each one of our chosen x values. This will give us a nice spread of data points so that we can easily plot our parabola. Now, once we plug each one of these values in, we want to simplify each expression in order to find y. So in our next column, we'll put our y values. We want to simplify each expression. This expression is simplified to 0. Our next expression is simplified to negative 3. Then we get negative 4, negative 3, and 0. So now we have x and y values. We can make ordered pairs. So in our last column of our table, we'll write our xy ordered pairs. Here, when x is negative 4, y is 0. So we have negative 4, comma 0. Here we have negative 5, comma negative 3. So we have negative 5, comma negative 3. Then comes negative 6, comma negative 4, which is our vertex. And then we have negative 7, comma negative 3. And finally, negative 8, comma 0. Now we have some ordered pairs that we can plot on our graph. So now let's graph. In our fourth step, we want to take each one of the ordered pairs that we found in step 3 and graph it. This will give us our parabola. So we'll draw our coordinate plane. And then we'll plot each one of our points. First, let's plot negative 4, comma 0. So we have negative 4, comma 0. Then negative 5, comma negative 3. Well, we have negative 5, negative 3, and we plot that point. Then negative 6, comma negative 4, our vertex. We plot that. Then negative 7, comma negative 3. And finally, negative 8, comma 0. Once we plotted each one of these points, we want to connect the dots to make our parabola. So here is what the parabola looks like for our equation. Now we can solve this. In our next step, let's look back at what our original equation was. Remember earlier when I said, replace this 0 with y. Well, now let's bring back 0. So on our graph, we're looking for any x value that when we plug it into this equation, will make it equal 0. In other words, we're trying to find the zeros of this graph. Any x value that we can plug in that will make our parabola equal 0 is a 0. In other words, if our y value is 0, what is our x value? We want to look at our x-axis and see any points that cross the x-axis. That's where y equals 0. So here's one right here, -8, 0. When x is -8, we can plug it in and we should get 0 for y. So -8 is one of our answers. Our parabola crosses the x-axis again at the point -4, 0. Again, y is 0. So when we plug this value for x in, we should get 0. Now that we've identified our zeros, let's double check to make sure that they're zeros. So we need to take each x value from this ordered pair, plug it into our parabola, and see if it equals 0. Let's start with -8. We take -8 squared plus 12 times -8 plus 32. Does that equal 0? Yes, it does. If we plug 8 in, we end up getting 0, which means that that's one of our answers. Now let's do the same thing with -4. We have -4 squared plus 12 times -4 plus 32. Simplifying, we get 0 here again, which means that we found our answers. By graphing this parabola, we found that our answers to this problem are x equals -8 and x equals -4.